trigonometry, and we stopped at sine rule and cosine rule. Today we'll be looking at something else, a fresh topic. Today we'll be looking at calculus. Alright, so let's just give our students 2 minutes to join. So if you're hearing me and you can see me, let me know, because we are live and we're about to start. All right, so let's begin. Let us begin today's class. Okay, so yesterday we stopped at sine rule and cosine rule. Today we'll be looking at something else. We'll be looking at calculus. That's our topic for today, calculus. So follow me as I'm going through calculus. Today we'll be looking at calculus. I'm looking at what? Okay. Well, let's look at it here. We're looking at calculus. That's what we're looking at today, calculus. Hope you're ready for today's class. Hope you are ready. I believe our students are with us now, and they've hooked up to today's class, so we can proceed. That's what I believe. And they're with us. So under calculus, we look at the what concept of limits. The concept of limits. I'm giving you the outline for today. After the concept of limits, we look at differentiation. After differentiation, under differentiation, we look at the various types of differentiation. So let's write the what? Types of differentiation. We look at the product rule. Look at the quotient rule. We also look at the chain rule. And we saw examples on each of them. We also look at differentiation of what? Of three trigonometric functions. Look at differentiation of trigonometric functions. Then we look at integration. We look at what? Integration. So these are the things we look at for today. We're looking at all these things one after the what? Other. We're looking at them one after the what? Other. So let us proceed. Let us proceed. Let us proceed. So let's start with the first one, concept of limits. What do you understand by concept of limits? When you hear the word concept of limits, what's the first thing that comes to your mind? Now, take down. The limit of a function is the value that the function approaches as the input x gets closer and closer to a specific number. The limit of a function is a value. The limit of a function is a value that the function approaches as it not it. So, as the input x gets closer and closer to a what? Specific number. So please write this down. The limit of the function is the value that the function approaches as the input gets, the input, remember the input is what? X. As it's getting closer and closer to a what? Specific number. It allows us to examine the behavior of a function at points where it might be undefined or difficult to what? Calculate directly. Now, mathematically, we say that the limit of f of x as x approaches a is equals to what? L. That's the mathematically representation of the limit of a function. That the limit of f of x as x approaches a is equal to what? L. Alright, now this means as x is getting nearer to a, the value of f of x, or the function f of x, is what? Getting closer to what? L. Take note, as x is approaching a, the function f of x is approaching what? Our output L. Now, let's take an example. Let's take a very simple what? Example. A very simple example. Now this is an example. This example we're using basic substitution. Now we are given a problem. So we should find the what? Limit, and this is our limit, two x squared minus 4x plus 1 as x approaches what? 3. Now they say we should find the limit of what? 2x squared minus 4x plus 1 as x is approaching 3. Now we are going to use the basic substitution method. The what? Basic substitution method. So our solution will be, since the function is a polynomial. Now this function, this is our function here, and it's a polynomial. A polynomial simply has a what? An unknown variable raised to a power and a coefficient, either what? Adding or subtracting themselves. So this is a polynomial equation. So since it's a polynomial, it is continuous everywhere. We can find the limit by simply substituting x as equals to what? 3 into this what? Expression. Then calculate for our final answer. So we have that lim 2x squared minus 4x plus 1 as x approaches 3 will be equal to what? 2 into what? Anywhere we see x, we put 3. 3 squared minus 4 into 3 plus 1. Now, we now have our answers to be what? 2 into what? 3 times 3 is 9 minus 4 times 3, which is 12, plus 1. We have our limit to be what? 2 times 9, we have 18 minus 12 plus 1, which will give us 18 minus 12, 6, plus 1, 7. So this is how we find our limit. So we can say that what? Lim 2x squared minus 4x plus 1 as x approaches 3 the limit of the function is approaching what? 7. Very simple. So this is how we find the limit, by simply substituting in the value of x into the expression of the function to get our value. Alright, let's look at another what? Example. Let's look at another example. Let's look at another example. Let's look at another example. Please hope the network is clear today, because I want you to be very sharp. I don't want it to be like the way it was the other day, where people were like, they cannot see me, they cannot see me. Alright, let's proceed. Now, example 2. This is for what? Indeterminate forms. So for indeterminate forms will be what? Factoring. Now the problem says we should find the limit of what? X squared minus 4 all over x minus what? 2, as x is approaching 2. Like this, approaching very well. As x approaches what? 2. Now our solution. Now, first of all, if we look at this function, we look at this limit now, we know that if we put direct substitution into the denominator, if we put x as 2, we will have that x as 2 will now be 2 minus 2, which will make our denominator 0. And once our denominator is 0, it simply means it is undefined. So we cannot find where this function is approaching. And we don't want that. We need our limit to be what? Defined. So now, what do we do? What do we do? Because even though we put it now, but let's put now 2 here. It should now be 2 squared, which is what? 4 minus 4. It should still give us 0. 0 over 0. It's not supposed to be like that. So it will not work. It will not work. So now, what do we do when we find out that if we input the value of x directly into the what? Expression, we get 0 over 0. What do we now do? This is an indeterminate form. That's what they call it, indeterminate form. You cannot determine where the limit is, where is what? Approaching. So because of that, we use factorizing method. Now watch. From our previous class, we said something about this. If you can remember, difference of 2 squares. When x squared minus 4, since the both of them are perfect squares and there's a negative sign, you can simply factorize them and it will now become what? X minus 4 and what? X plus 4. X minus 4 and what? X plus 4. I've said this thing in our previous classes. I've said this, sorry, not 4. Yes. I've said this in our previous classes. Not 4, 2. They are perfect square. 2, not 4, sorry. Yes. So now let's confirm if it's going to work. This is simply what? X into what? 2. That's x times everything in this bracket. X into what? X plus 2 minus 2 into what? x plus what? 2. Now x times x will give us what? X square. X times 2 will give us what? Plus 2x. Minus 2 times x will give us what? Minus 2x. 2 times 2 will give us what? Plus 4. So now minus 2x will cancel plus 2x, and we'll be left with what? X square plus 4. So we can simply say x minus 2 and x plus 2 is the same thing as what? X square plus 4. So now for us to take our limit, our new limit will now be lim x minus 2 times what? X plus 2 all over what? X minus 2 as what? X approaches what? 2. Now this will be our new what? Limit. So if we do direct substitution now into this, before we do direct substitution, we know that we can cancel out. X minus 2 will cancel out what? X minus 2. So we left with what? X plus 2. So if we substitute in the value of x as 2 from x approaching 2, we will now have what? 2 plus 2. And we now have our limit of x minus 2, x plus 2 all over x minus 2 as x approaches 2 will be equals to what? 4. Very, very simple. So take note of what happened here in this question. We first of all tried our direct substitution into the function, and we got indeterminate form because we got our answer as 0 over 0, which is undefined. We cannot determine where the function or the limit is approaching. So we decided to what? Get the factors of the numerator. And we got the factors of the numerator as x minus 2 and x plus 2. So instead of putting x square plus 4, we substituted it with what? X minus 2 and x plus 2. Then next up, we cancelled out and we're left with just what? X plus 2. So next up, we substitute in our value for x into the expression to get 2 plus 2, and our final answer for the limit was 4. So we can say that lim x minus 2 into x plus 2 all over x minus 2 as x approaches 2 is what? 4. So as x is approaching 2, this function is approaching 4. Alright, so next up, let's look at something else. Let's look at differentiation. Differentiation. Let's look at differentiation. We are done with the concept of limit. Let's look at differentiation. So we're looking at what? Differentiation. So if you have any question on the limit, please let me know in the comment section. If you understood what I just explained for the substitution method or the what? Undefined method as the indeterminate factor or the indeterminate limit, let me know. Let me know in the comment section so we can proceed. Differentiation. Alright, let me know in the comment section. Let me know. Chisom Divine, welcome. Eze Joma, welcome. Wadi Tonye, welcome. Okay, let's proceed. So take down, differentiation measures the instantaneous rate of change or the slope of the tangent line to a curve at any point. I repeat, differentiation measures the instantaneous rate of change or the slope of the tangent line to a curve at any point. So that is what differentiation states. So the moment you are measuring how an object is changing position from one point to the other on a given line, that's the tangent line, then you are talking about what? Differentiation, which is rate of change. Now, for polynomials, we use the power rule, which is the most fundamental tool in calculus. The power rule. So now, let me give you an example of what the power rule means. If we have a function f of x, and that function f of x is given as x raised to the power what? N. Now, if we are to differentiate or find the derivative of this function, we have that the first derivative of f of x, this symbol represents the first derivative of f of x, will be equal to what? The power, you multiply it by this polynomial, which is x, then you add 1 to the power, that is n. No, you don't add 1 to the power, you subtract 1 from the power, n minus 1. So this is how you find the what? First derivative of this polynomial, and this is called the what? Power rule. The power rule. The power what? Rule. So now let us apply it. We'll apply it in an example, then we'll now solve examples or different types of differentiation. So this is what? Power rule. Let's apply it first. The power rule. Let's apply the word power rule. Now, if we're given a function f of x is equals to 4s cubed minus 5x squared plus 7x minus 10. Now, and we're asked to find the what? First derivative of this polynomial expression. Now, from the power rule, recall, we said that the power rule is simply what? The power, that's, we have 3 as the power here, we have 2 as the power here, we have 1 here, times the polynomial function raised to the what? Power minus 1. So we are applying this in each of them. So now for the first one, we have 4x raised to the power 3 to now be what? The power, which is n, you bring it out, 3 times the 4x raised to the power what? 3 minus 1. I see what I did there. Now, n here is what? 3. So we'll do what? N, which is 3, times 4x raised to the power n minus 1. And n is what? 3. So it will be what? 3 minus 1. So we have our final answer to be what? 3 times 4, 12. X, 3 times 4x is 12x. 3 minus 1 is what? 2. So we have what? If we take the first derivative of 4x raised to the power 3, we have 12x raised to the power what? 2. Next up, we'll do the same thing for minus 5x squared. So if we do the same thing for minus 5x squared, we know that n is the power, so it should now be 2 times what? 5x into what? 2 minus 1. 2 times 5x is what? 2 times minus 5x is what? Minus 10x. 2 minus 1 is what? 1. X raised to the power 1 is still same thing as x. So now for this one, let's do this one. If we have 7x, remember the power here is 1, right? So it's not be what? 1 times 7x raised to the power what? 1 minus 1. Now, 1 times 7x give us what? Plus 7. Now, watch. 1 minus 1 is what? 0. I seen it. 1 minus 1 is 0. So now, okay, let's assume we remove this bracket. Let's remove this bracket so that this power will affect only x. Let's remove this bracket so that the power will be affecting only x. Let's remove this bracket so that the power will affect only x. So x raised to the power 1 minus 1 is what? 7 what? X raised to the power 0. And x raised to the power 0 is same thing as 1. So 7 times 1 will be what? 7. So we left with what? 7. Here is the same thing, we have gotten 10x. Then now this is a constant, and if you differentiate the constant, you will get what? 0. So this will be our what? Final answer. This will be our what? Final answer. So it will now be 12x squared minus 10x plus 7. So if you notice, anytime we are differentiating, the polynomial with the highest power is always being subtracted by 1. This one is subtracted by 1. This one is subtracted by 1. So this is why we got this expression. So let's move on. Let's take an example using a negative and fractional index. Let's take another example. Using a negative and fractional index. Let's take another example. Please, if you understood this point I just made now, let me know in the comment section. If you understood this example now, just let me know now. Let me know in the comment section. If you understood this example, let me know. Alright, let's proceed. So if they give us a question like this, find the y over the x for y is equals to what? 2 over x squared plus root x. Now, in this one, we have both a negative and a fractional exponent. We have a negative and a fractional exponent. Please take notes. negative, and fractional exponent or index or power. Remember from our laws of indices, when I told you that exponent simply mean index or power. So now, the first thing you need to do is to put it in the form of an indices. Now, so our solution will be what? First of all, we represent y in form of what? An indices. Now, this is simply what? 2 into, I see what I'm doing. This is simply 2 into what? X raised to the power what? Minus 2. Remember, when we have x raised to the power minus 2, for our negative index law of indices is simply what? 1 over what? X squared. So if we do 2 times 1 over x squared, we will have what? 2 over x squared. So we are simply what? Reversing 2 over x squared to get this. Now, instead of us to put this 2 over x squared, we will reverse it and we will now have what? 2 times x raised to the power minus 2. X raised to the power minus 2 is what? 1 over x raised to the power 2. So understand how we got 2x raised to the power minus 2. Now, plus, now, from our law of indices, that's the fractional index, we know that x raised to the power 1 over 2 is the same thing as what? Root x. So instead of writing root x, we will now write what? X raised to the power what? 1 over 2. So this is how we are going to what? Represent them. Then from here, we will now take dy dx. dy d what? X. So we are differentiating y with respect to what? X. That's our derivative. This dy dx can also be written as the first derivative. So this is same thing as this, dy dx. So let's go. So now, from our power law, we say that 2x raised to the power minus 2, we know that minus 2 is the power, so it will be what? N. Minus 2 is the power, so it will be what? N. So it will be what? Minus 2 times 2x raised to the power what? Minus 2 minus what? 1. Plus, now the power now, the n power is what? Half. So it's now be 1 over 2 times x raised to the power what? 1 over 2 minus 1. Please excuse me, let me just answer this call. Hello, Chi? Okay, I'm in a class. I'm in a class now. I'm in my class. Can you just give me like some minutes? When I finish, I'll turn on the gen. Alright, sorry for the break in transmission. My sister was calling me to turn on the gen. So I have to let her know that I'm in a class, and if I leave this class, it's not be good for me to just leave my students to go and turn on the gen. There's no light, but I'm using my energy bulb, so we'll manage. Alright, let's proceed. So we have that dy over dx will now be what? Minus 2 times 2x will be what? 4 minus 4x. Minus 2 minus 1 will be what? Minus 3. Plus, now, half times x, it will be same thing as what? X over 2. Then 1 over 2 minus 1 will give us what? Minus 1 over 2. So this will be our answer. This will be our what? Final answer. Very, very what? Simple. So you need to understand. That's why I was teaching you indices, because you need the knowledge of indices in calculus. Yes, you need it. You need the knowledge of indices in calculus, and you need to understand what a polynomial is. So when you see all those things, you will not be what? Confused. So let's proceed. Now let's look at some types of what? Differentiation. Okay, before we look at some types of differentiation, like the product rule, the quotient rule, and the chain rule, let's look at differentiation of what? Trigonometric function. Differentiation of what? Trigonometric function. So we have differentiation of trigonometric functions. Alright, so now first of all, know that trigonometric differentiation involves finding the rate of change for functions that oscillate. So if a function is moving in a circular path, we will be able to use this type of differentiation to find the function. Let's say it's changing from this position to this position to this position. So we're able to find the rate of change of this object by differentiating it. So now trigonometric differentiation, take note, trigonometric differentiation involves finding the rate of change for functions that oscillate, like sine and cosine. These are essential for modeling waves, alternating current, and harmonic motion. The two most fundamental rules are please take note of this. Two most fundamental rules. Now, the first rule states if f of x is equal to what? Sine x, then the first derivative of f of x will give us what? If you differentiate f of x in reference to sine x, which is a trigonometric differentiation, we'll have our answer to be what? Cos x. That's the first rule. And the second rule states that if f of x is equal to what? Cos x, and want to differentiate, that means then the first derivative of f of x in relation to cos x will be equal to what? Minus sine x. Please write this down. Write the both of them down. They are very, very, very important, because for you to differentiate any trigonometric function at all, you must know these two fundamental rules. You must know these two what? Fundamental rules. Okay, should I go and turn on the gen? Will you just give me like 2 minutes? Let me run and turn on the gen. then I'll be back. Please give me like 2 minutes. Let me just turn on the game, then I'll be back. Thank you. Just 2 minutes, I'll be back. Alright, I'm back. I just turned on the gen. I'm back. So let's take examples. Let's take some examples. So if we're asked to what? Differentiate. If we're asked to differentiate y is equals to what? Is equals to let's say 3 sine x plus 4 cos x minus x squared. So if we are asked to differentiate this expression or this function, now take note, f of x is the same thing as y. So if I say f of x, I'm still representing y. And if I say the first derivative of what? X, I'm simply saying what? dy over dx. So I'll be using this interchangeably. So please take note of that. In case I use anyone, not be confused. They mean the same thing. F of x mean y, and first derivative of x simply means dy over dx. So our solution will be dy over dx will be equals to, now we want to differentiate this. If we differentiate sine x, what are we going to get? Cos x. So if we differentiate 3 sin x, we are going to have what? 3 cos x. We are going to have what? 3 cos x. Please take note. 3 cos x. So this is how we apply the rule. It's very straightforward. Very, very, very straightforward. Now, watch. We have plus 4 cos x. If we differentiate plus 4 cos x, if we are differentiating cos x, we are having what? Minus sin x. So if we differentiate plus 4, if we differentiate cos x here and plus 4, it should now be what? Minus sin x times what? 4, which should now be what? Minus 4 sin what? X. Then if we differentiate x squared, we now have what? Minus what? 2x. It should now be what? The power, that's n times x all over n minus 1. Remember, from our product rule. So n here is 2, which is 2 times x raised to the power 2 minus 1. So x raised to the power minus 2, x raised to the power 2. 2 minus 1 is what? 1. So x raised to the power 1 is still what? X. Please take note of that. Alright. So let's proceed. We are done with this question. This is the final answer. Very, very simple. Let's take another. Let's look at something else. Let's look at something else. Let us look at what? Something else. Alright. Please take note of these two rules. Let's look at another form of what? Differentiation. Another form of differentiation. Or another type of differentiation. Okay. Alright, if you can hear me, you can see me, let me know. Let me know if you are still with me. Alright, let's proceed. Now, we're looking at what? Product rule. Product rule. I will first of all write 3 different formulas that you're going to use. One will be for product rule, the second one will be for quotient rule, and the third one will be for what? Chain rule. So please watch closely. And you use them when you have questions that requires either of them. Now for product rule, the formula for dy over dx is equals to what? U dv over dx plus v du over what? Dx. That's the product rule what? Formula. This u and this v, they are big, but I'm writing them because of space. So it's u times dy over dx plus v times du over dx. So now let's take an example so you understand how we apply it. Let's take an what? Example. Because anything we are doing, you need to follow it up with example. If not, you will not understand it. Now they said example. find dy over dx if we are given y is equals to what? In bracket open 6x plus x raised to power 2 times x times s cube plus 3. So now this is what we are given, and they are telling us that we should find dy dx. That means we should differentiate this function. But now looking at this function, we know that everything in this bracket is what? Multiplying everything in this bracket. And we know that product simply means multiplication. So if they tell us to multiply these two, we'll take the first one as u and we'll take the second one as what? V. So now if we have this one as u and this as v, and we have our product rule formula as this, dy dx is equals to u dv over dx plus v du over dx. So what we are going to do is we'll find dv over dx. Now for dv over dx, that means we are differentiating what? This. We say that v is equals to this. We say that what? We are making this v. So v is equals to what? S cube plus 3. And they say we should find what? Dv over dx. Let me take it up. So you are differentiating v with respect to x, so it's dv over dx. Now let's use our what? Rule. The first thing is to take the power, multiply by the what? Polynomial x, or the variable x. Let's not use polynomial. The variable x, then subtract 1 from the power. So it should now be what? 3 times x raised to power what? 3 minus 1. If we differentiate the constant, it will turn to what? 0. So we have that dv all over dx is equals to what? 3 times x will give us 3x. 3 minus 1 will be what? 2. So we now have our value for what? Dv over dx. We already have our value for u. We have our value for v. So now what we are looking for now will be du over dx. Now we say that u should be equal to everything in this bracket, which is what? 6x plus x what? Squared. Therefore, if we differentiate u with respect to x, we will have that du over dx will be equals to, now the power here is what? 1, x raised to power 1. So 1 times 6x will give us what? 6x. But now this x raised to power 1, okay, will give us 6x. Let me write it down. Now we'll have 6x is raised to power 1, we'll see minus 1 from it. So it's now be 6x 1 minus 1. Now 6x raised to power what? 1 minus 1. Now similarly, plus, we'll now do 2 times x, will now be what? 2x raised to power what? 2 minus 1. So we'll now have that du over dx will be equals to what? 6 x raised to power 1 minus 1 is x raised to power 0. And x raised to power 0 is what? 1. So it will now be 6 times 1, which is 6, plus 2 into x raised to power 2 minus 1. 2 minus 1 is 1, so x raised to power 1 is what? X. So we have gotten our value for what? Du over dx as 6 plus 2x. So we have everything. So the next thing is to what? Substitute into our equation. So we have our solution that dy over what? Dx will be equals to, now they say u, where's our u? Is our u 6x plus x squared 6x plus what? X squared times dv over dx. What is dv over dx? dv over dx is what? 3x squared. 3x squared plus v. Where is our v? This is our v. S cubed plus 3. S cubed plus 3 into du over dx. Our du over dx is what? 6 plus 2x. 6 plus 2x. So this is what we will have when we differentiate y with respect to what? X. Since there are two different expressions multiplying themselves, is a what? Product rule. So we'll use this formula and apply it to get this. So now from here we what? Simplify. From here we what? Simply what? 5. So if we simplify, we will now have what? 3x squared times 6x will give us what? 18s cubed plus 3x squared times s squared will give us what? 3x raised to the power what? 4 plus, now we'll expand these two. To do that, we have 3 times 6 will give us what? 6x cubed. 3s, sorry, I said 3 times 6. S cubed times 6 will give us what? 6s cubed. S cubed times 2x will give us what? Plus what? 2x raised to the power what? 4. Now we are done with s cubed. Now let's take 3. 3 times 6 will give us what? Plus 18. And 3 times s 2x will give us what? Plus 6x. So next up is to what? Collect like terms. So let's clean the board so we can have space. We are done with the formula for product rule, so we can clean it. So now if we simplify this further, we now have that what? Dy all over dx will be, let's collect like terms. 3x raised to the power 4 is here. 3x raised to the power 4. So let's add these two, they are like terms. 3x raised to the power 4 plus 2x raised to the power 4 will give us what? 5x raised to the power 4. So we started with the polynomial with the highest power. Now let's go to the x raised to the power 3. We have x raised to the power 3 here, we have x raised to the power 3 here. 18x raised to the power 3 plus 6x raised to the power 3 will be what? Plus 24x raised to the power what? 3. So we are done with this, we are done with this, we are done with this, we are done with this. So now we have 6x, so it will be plus 6x, we are done with this. We now have 18 plus 18. So this will be our final answer, the most simplified form. This will be our final what? Answer. Except you want to factor out x here. You can still factor it out, you can still bring out x again, but this should be our what? Final answer. So this is all we have for what? Product rule. Product rule. This is all we have for what? Product rule. Please, if you understood what I just explained, please let me know in the comment section so we can proceed to what? Quotient rule. If you understood what I just explained now, please let me know in the comment section so we can proceed to what? Quotient rule. Please, are you understanding what I'm writing here? So we can proceed to quotient rule. Alright, I believe we all understand. I believe we all understand. Okay, let's move to what? Quotient. Let's move to quotient rule. Let's move to quotient rule. So for quotient rule, the formula is very simple. The formula is what? Very what? Simple. Let's say we have let y be equals to what? U over v, which means that the denominator will be v and the numerator will be what? U. Now we know that u and v will be gotten from our function x, from our function let me know this hour, from the function x. So our formula will be what? The what? Y over the x will be equals to, now take note of this, look at it closely. We'll start with v du over the x minus u dv over the x. Are you seeing it? All over what? V squared. So please write this formula somewhere, because we'll be taking an example now. So please write this formula somewhere. Now from quotient, y is equals to 3x squared plus 5x plus 5x all over 3x. We're given this as this. I told you that y is same thing as f of x. So we're given our function as this, and we're asked to differentiate it. So before we differentiate it, remember y is equals to u over v. So this one will be u, and this will be what? V. So we say let u be equals to the numerator 3x squared plus 5x. Now if we differentiate the u with respect to the x, that is differentiating u with respect to the x variables, so I will get this. Now we have u, we are taking u as this, so we have u already. Now I want to find the u over the x. To do that, we now have, if we use our differentiation rule, we take the power multiplied by 3x. So 2 times 3x will give us what? 6x. Then 2 minus 1 will give us x raised to the power what? 1, which is the same thing as x. Plus, if we differentiate 5x, we'll have, now x is raised to the power 1, right? So it will be 1 times 5x, which is what? 5x. Now it's not be x raised to the power 1 minus 1. Let me write it down like this so you understand. This will be raised to the power 2 minus 1. So you understand. So now we have that the u over the x will be equals to what? 6. X raised to the power 2 minus 1 will be what? X raised to the power 1, which is same thing as x. Then we have that plus 5. X raised to the power 1 minus 1 is x raised to the power 0, which is what? 1. X raised to the power 0 is same thing as 1. So 5 times 1 is what? 5. So we have the u over the x as 6x plus 5. So we have gotten this. We have gotten these two, right? Now, they said let's take v as v is equals to what? 3x. I seen it. Our v is the denominator, which is 3x. Now, the v over the x will be equals to, we are getting v, we are looking for the v over the x. The v over the x will now be equals to what? If we differentiate 3x, we'll be left with what? 3. You know how we got it? Because see this one, if we differentiated 5x, we got 5. So if we differentiate 3x, we'll get what? 3. So now we are getting u, we are getting v, we are getting the u over the x, we are getting u, we are getting what? The v over the x, and we already have our value for v. So we simply what? Substitute in to get the value of what? The y over what? The x. So we have that the y over the x will be equals to, now v is what? 3x. So we have what? 3x times the u over the x. The u over the x is what? 6x plus 5 minus, let me clean this v is too big, let me make it smaller, minus u, where is our u? 3x squared plus 5x, 3x squared plus 5x into the v over the x. The v over the x is what? 3. All over what? V squared. What is our value for v? Our value for v is what? 3x. So it's what? 3x all what? Squared. Now, this is what we will have as what? The y over the x. So now that I have gotten it, let us simplify further to get our final answer. So I can clean the, we have used the equation, we have used this formula, so I can clean it, right? Oh my god. Okay. I forgot to put 4 inside the JAMB. Alright, let's proceed. So if we clean here, let's clean here instead. So we now have that the y all over the x will be equal to 3x times 6x equals what? 18x squared. 3x times 5 will give us what? Plus 15x plus 15x. Now minus 3 times 3x squared will give us what? 9x squared. 3 times 5x will give us what? Plus 15x. All over 3x squared will be what? 9x squared. Now let's open up this bracket. We have gotten this. Now let's open up this bracket. So we have that what? The y all over the x will be equals to what? 18x squared, that is this, plus 15x, which is this, minus times this will be what? Minus 9x squared, minus times this will be what? Minus what? Minus what? 15x all over what? All over what? 9x squared. So now we'll take like terms. 15 plus 15x will cancel out, minus 15x. We'll now be left with what? 18x squared minus 9x squared. 18x squared minus 9x squared, we have that the y over the x is equals to what? 18x squared minus 9x squared will be left with what? 9x squared. All over what? 9x squared. So now 9x squared cancel 9x squared, so we have that the y over the x is equals to what? 1. So this is our final answer using what? Quotient rule. So we have that the y all over the x is equals to what? 1. Please let me know if you understood this explanation in the comment section. Let me know if you understood this explanation in the comment what section. Okay, Emmanuel Oladuton. Alright, let me know the part where you are having it difficult, you're finding it difficult to understand. So I'll expatiate on that part. Are you just joining us? Because I'm not, are you just joining us? Let us know. Brainy Benedict. Okay. Okay, let's proceed to chain rule. Let's proceed to chain rule. Let's proceed to what? Chain rule. Okay, before I do that, let me recap this quotient rule. Since you don't understand. Now, we're given a question. Our question was y is equals to this. Not this. Okay, the initial question, I've cleaned the initial question. So from the initial question, we are given a value of y. We are given equation in fraction form, and we know that they were dividing each other. So anytime we see two expressions dividing themselves, we simply what? Apply the quotient rule to find their what? Derivative. Now, this is the equation for quotient rule, where we have v du over dx minus u dv over dx all over v square. Now we take the denominator as v and we take the numerator as u. Look at it here, u and v. So now what we are going to be looking for, since we already have v and u, will just be du over dx and dv over dx. Now we differentiated the value we got for u with respect to x, we differentiated the value we got for v with respect to x. We got dv over dx and we got du over dx. So we have gotten all the things we need. We'll put them into the equation, into the formula, and we'll get our final answer as what? The y over dx as 1. So let's proceed. We are done with quotient rule. Please, if you are just coming and you don't understand, please, you can rewind the video, or when we are done with the stream, you can watch it again, and I bet you are going to understand. Because that person that said he doesn't understand, he just coming now. I've just seen him in the comment section for the first time. So let's proceed. Let us what? Proceed without any hesitation. You can also chat me up on WhatsApp 081-263-88049 if you have any question, or if you're not in Nigeria, you can add it +234-81-263-88049. If you have any question or you're confused, chat me up on WhatsApp. I'll answer your question. Alright, chain rule. We're looking at now chain rule. Chain what? Rule. Now, for chain rule is simply what? Function of a function. If y is a function of u and u is a function of x, then we can say that y is a function of a function. Please take note of what I'm saying. Chain rule is simply what? Function of a function. Now, I said if y is a function of u, comma, and u is a what? Function of x, comma, then we say y is a what? Function of a function. Let me explain this mathematically. That is y now is equals to what? F of u. That's what I mean by if y is a function of u. Now you differentiate y with respect with u. That means you have what? Dy over du, right? Keep it to one side. Now, and we say and u is a function of what? x. Now if we differentiate u with respect to x, we have what? Du over what? Dx. We'll keep it what? One side. So chain rule states that if y is a function of u and u is a function of x, that means for us to get dy over dx, we will now join the two of them. We will multiply them. So we have what? Dy over du, which is this, times du over dx. So this is a formula for chain rule. If you observe closely, since you are multiplying them, if you cancel out this one and cancel out this one, we will be left with what? Just dy over dx, and it's equals to dy over dx. So this equation is what? Correct. So this is what all this grammar means. That if y is a function of u and u is a function of x, that means if you combine the two of them, that's dy over du and du over dx, we'll be able to get what? Dy over dx. So all the trouble we are going through is to just find what? Dy over what? Dx. Please take note of that. Very, very important. So let's take an example on chain rule. Let's take an example on what? Chain rule. Alright. Please pay attention. This part is very important. Very, very important. Very, very important. If you don't pay attention, you might miss it. So please pay good attention. Pay good attention. Pay good attention. Alright, for chain rule, we have an example. We say evaluate dy over dx. I told you we are just looking for dy over dx. When y is equals to, watch closely, 10x, I see it, plus x raised to the power 4 raised to the power what? 5. Now, once you see, now from a lot of indices, this is what? Power of the power law. Because this 5 now is going to multiply all the powers, it's going to multiply this power, it's going to multiply this power, so it's power to power law. So once you see y in form of this expression, just know that you are going to use what? Chain rule. Just know it. Put it at the back of your mind that you are going to use chain rule. And we know the formula for chain rule, that dy over dx is simply what? Dy over what? Du times du over what? Dx. So now, where is our u? We don't have u here, right? Let's sign. So our solution will be, since we don't have u, now we'll say let this now represent what? U. Let this represent u. Let it what? Represent what? U. So now everything in this bracket will be what? U. So you can see that y is equals to what? U. And u is raised to the power 5, right? So it's now u raised to the power what? 5. So now, since we have put y in terms of the function, in terms of u, we can now find dy over du. I see it. So now we say dy over du. Without doing this, you cannot get this dy over du because there is no u variable here, just x. So you have to put everything, all the x now, everything in form of u. So you can get dy over du. So now that I've put it in form of u, we will now use our normal differentiation law, which says that what? N times what? X raised to the power n minus 1. Now, n is what? 5. So it now be what? 5 times u raised to the power what? N minus 1. That's 5 minus what? 1. So we have that dy all over du will be equal to what? 5u raised to the power what? 4. I see it. Very simple. Next up, we will now look for what? Du over what? Dx. Now, we said that u is equal to everything inside this bracket, that is what? 10x plus x raised to the power 4. We say that u is everything inside this bracket. That's why we are able to say y equals to u raised to the power 5, because u is everything inside the bracket. So now we have u here and we have x here. So we can now say du with respect to what? Dx. Now, if we differentiate u with respect to x, we will now use this same law. The power here is 1, so it is 1 times x, that's 1 times 10x, will give us what? 10x raised to the power what? 1 minus 1, plus 4 times x will give us what? 4x raised to the power what? 4 minus 1. So we have that du over dx will be equal to what? 10 raised to the power 10 times x raised to the power 1 minus 1. X raised to the power 1 minus 1 is 0. So 10 times x raised to the power 0 is 10 times 1, which is 10, plus 4 times x raised to the power 4 minus 1, 3. So now, if you watch closely, we have gotten our value for what? Dy over du as 5u raised to the power 4. And we have gotten our value for du over dx as 10 plus 4x raised to the power what? 3. Alright. So now, the next step, they say we should find what? Dy over dx. So to do that, we have that dy all over dx will be equal to, now we will impute this value, dy over du is what? 5u raised to the power 4 times what? Du over dx is what? 10 plus 4 raised to the power what? 3. I see it now. So now we can all multiply u and x. We have u in terms of x, so we'll simply substitute u as the original value, which is 10x plus 4x plus x raised to the power 4. So we now have what? Dy over dx. Since our original value for u is what? 10x plus x raised to the power 4, we now have dy over dx equals to 5 times what? The original value of u, we put u, 10x plus 4 plus x raised to the power 4, plus x raised to the power 4, then times what? 10 plus 4x raised to the power what? 3. So 5 times 10x will give us what? 50x plus 5 times x raised to the power 4 will give us what? 5x raised to the power 4. Now everything in this bracket, we multiply everything in this bracket. 10 plus what? 4x raised to the power what? 3. So we now have that 50 times 10, 50x times 10 will give us what? 500x. 50x times 4x raised to the power 3 will give us what? Plus what? 200. I seen it. Plus what? 200x raised to the power what? 4. Now we'll do this one. 5x raised to the power 4 times 10 will give us what? Plus what? 50x raised to the power 4. 5x raised to the power 4 times 4x will give us what? Plus 20x raised to the power x raised to the power 4 times x raised to the power 3, which will be x raised to the power what? 7. I seen it. So now our dy over what? Dx. We are simply looking for dy over dx. Now we'll simplify this. We'll collect like terms. Now let's bring out this one with the highest power. So it's now what? 20x raised to the power 7. 200x raised to the power 4 plus 50x raised to the power 4 will be what? Plus 250x raised to the power 4 plus what? 5x. So this is a simplified form. So this will be our what? Final answer. So this is how we apply what? Chain rule. Very, very simple. This is how we apply chain rule. Please, if you don't understand this, just watch the video again. After today's class, just watch it. The link will be there. Watch it again. You can reduce the speed if I'm too fast, and you see that you understand it. It's very, very what? Simple. So we are done with three different methods of what? Differentiation. There are other methods of differentiation, but this is our main focus for today. So let's look at integration before we call it a what? A day. Let's look at what? Integration. Let me just introduce integration to you. Then we'll call it a what? A day. Let's look at integration before we call it a day. Please, I hope it's not getting blurred. I hope it's not getting blurred. Alright. Please, do you understand? Let me know in the comment section if you understand before I proceed. Right, let's proceed. We are rounding up. So this is the final rush. Let's look at what? Integration. So we'll call it a day. Integration. This is my duster, a very big duster. I have to turn it to duster because of this class. Now, integration. Now, take note. Integration is simply the reverse or the opposite of differentiation. If differentiation is telling us the rate of change of a body, then integration is simply telling us the total amount of change that occurred by that body. Or the, let me define it well for you now. Take note. Integration is the process of finding the antiderivative, that's the opposite of derivation, that's the derivative. If differentiation tells you the slope, integration tells you the total accumulation. Please take note of that. For now, we'll focus on just one part of integration. That's the indefinite integral, which says that now we'll just focus on the what? Indefinite integrals. Indefinite integrals. That's what we'll look at. Where we always have a constant c, because the derivative of any constant is what? 0. So we must have a constant c at the ending, because normally if we differentiate this now, let's say 2x squared plus 2. If we differentiate this, we have y equals to 2x squared plus 2. If we differentiate y in respect to x, we will now have that what? 2 times 2x will be what? 4x raised to the power what? 2 minus 1. If you differentiate this constant, it will turn to what? 0. I seen it. So we will now be left with what? 4x as our differentiated value. So if we are integrating, if we are to integrate this 4x, when we get our integration of what? 4x, we'll add a constant c. This constant c is this value that we eliminated. So integration is like the reverse of differentiation. Now, if we are to integrate this, we'll simply do what? Add 1 to the power, then divide it by 2. So this will now be what? 4. This will be what? This is going to be 4 what? X what? 1 x to the power 1. We'll add 1 to it plus 1, which is 2, all over what? 2. So if we differentiate this, if we integrate this, we'll now do 2 times cancel out this, we'll now be left with what? 2x squared plus our constant c. I seen it. So now this is going to be this. As I said, if differentiation will give you 4x, integration will give you back this equation. I seen it. So the opposite, the antiderivative, this is called a derivative. I told you now that dy over dx is the same thing as the first derivative of what? X. So now this is the first derivative. So if you take the antiderivative of this, we will now get what? This. So let's proceed. I'll give you the formula. Let me give you the formula for what? Integration. Let me give you the formula for what? Integration. Alright. Integration is also very simple. After I give you the formula, then just look at one more example and we'll call it a day. So the formula is what? The integral of what? X raised to the power what? N dx. Now they say we should, if they say we should integrate x raised to the power n dx, we will now have what? Now this dx simply means we are integrating only the x variables. So everything here should be in terms of x. So any x you see here with any power, we integrate it. So that's why we have this dx. So this is the integration of x raised to the power n dx. So we have our answer as what? X over what? N plus 1. Like I told you, we are adding 1 to the power. Then this n plus 1 will also be at the denominator. N plus 1. Plus our constant c. So this is the formula for integration. And take note, where n should never be equal to what? Minus 1. Because if you put n as minus 1, we now have what? Minus 1 plus 1, which is what? 0. So n can never be what? Minus 1. Please take note of that. Please take note of that. Where n can never be what? Minus 1. So this is the formula. So now let's solve an example. Let's solve an example. They will call it a day. Let's solve an example. They will call it a what? Day. They say we should differentiate what? 6x. Okay, let me write it like this. Let me write it on this side. They say we should differentiate. Sorry, integrate, not differentiate. Integrate. They say we should integrate. Find. The question goes like this. Find the integral of what? 6x squared minus 4x plus 3 d what? X. So now, remember I told you once you see the x here, we know that everything was differentiated with respect to only x. So it was only x they were touching. So now to do the reverse, our solution will now be what? First of all, you integrate the first part, 6x squared, minus you integrate the second part, 4x, plus you integrate the constant, 3. Then, okay, this constant does not have x value, so you cannot integrate it. Just write plus what? C. Okay, no. You integrate it, you integrate it. Because now this 3 is x raised to the power 0. This 3x is x raised to the power 0 because x raised to the power 0 is same thing as 1. So we integrate this 3 too. I see it plus our constant c. So let's do that. So now from this equation, from this formula, if we integrate 6s squared, simply our n here is 2. I seen it. So now using this formula, if n is equal to 2, we will now be left with what? 6x n plus 1, that's 2 plus 1, all over what? N plus 1 is what? 2 again. Our n here is 2. Watch. Our n is 2. All over 2 plus 1. So we'll be left with what? 6x raised to the power 3 all over 3. Now, 3 will cancel 3 and we'll be left with what? 2s cubed. I seen it. We'll be left with what? 2x cubed. So we can clean these parts. and write what? 2x cubed. We are done with that one. Now let's move to the next one. If we integrate 4x, now our n here, the power for x here is what? 1. I seen it. X to the power 1 is the same thing as x, so take note of that. So if we integrate it, we will now have what? 4x raised to the power n is 1, right? Plus 1 all over n plus 1, that's 1 plus 1, which will now give us what? 4x raised to the power 2 all over what? 2. Now 2 divided by 4, 2 get 1, 2 get 2, so we left with what? 2x squared. So we can clean this part and write what? 2x squared. I seen it. So next up, we integrate the third part. Now, we're integrating this. This was 3 here. I seen it. This was 3. I added x raised to the power 0 because there's an x here, but there's no power. Because once you're differentiating everything here, since it's in respect to x, x must be in all of them. So if there's no x here, you add x raised to the power what? 0. So that you won't be confused. Now let's do that. So now we have what? Our n value here is what? 0. You know, the only thing that we cannot accept as our n value is -1, but we can accept our n value as 0. So we will now have what? 3x raised to the power n plus 1, that's 0 plus 1, all over what? Mosquito rest. 0 plus 1, which will give us what? 3x raised to the power 0 plus 1 is what? 1, which is 3x raised to the power 1, which is the same thing as what? 3x all over 0 plus 1 is what? 1, and 3x all over 1 is the same thing as what? 3x. So we can clean here and write what? 3x plus our constant c. So this will be our final answer after what? Integration of this function. So thank you for staying to the end of this class. Hope you enjoyed your time here. Please, if you have any question, you can get my WhatsApp number and contact me. Send me your question and I will help you solve it. My number is 081-263-88049. But if you are out of the country, you use this country code +234-81-263-88049. See you in our next class, which is tomorrow, the same time and the same venue, 8 o'clock. Thank you very much.